Hello my dear students, this is ASHUTOSH DWIVEDI. Welcome you all again on my YouTube channel. Dear students, today we will discuss a very important chapter, that is current electricity. This is the third chapter of your NCERT part 1, right? Dear students, as we all know that without electricity we can't survive. So this is very important chapter for understanding point of view and for as well as for your board point of view, right? So these are the content of this chapter. First topic we have to discuss electric current, second Ohm's law, resistance and resistivity, current density, drift of electrons and resistivity, mobility, limitations of Ohm's law, color code of carbon resistor, temperature resistance of resistivity, electrical energy and power, and last one combination of resistors. Dear students, at a glance we have to see these topics, we have to understand these topics in a very short duration of time, right? So come to first one, electric current. As we all know that electric current is defined as a flow of charges per unit time. The amount of charge flow per unit time is known as electric current. As we all know, the strength of electric current can be measured by the amount of charge flow per unit time, right? So on the mathematical formula I equal to Q upon T, we can define electric current. And as we all know that when the time passes, the amount of charges increases, so that the amount of electric current increases. And the SI unit of electric current is in ampere, है ना? हम लोग किस में मेजर करते हैं? एम्पियर में मेजर करते हैं. सो द बेसिक यूनिट ऑफ इलेक्ट्रिक करंट इज इन एम्पियर, दैट इज डिनोटेड बाय कैपिटल ए, राइट? हमें बच्चों ध्यान रखना है कि जो इलेक्ट्रिक करंट होती है दैट विल फ्लो फ्रॉम पॉजिटिव टू नेगेटिव टर्मिनल्स, एंड अपोजिट टू द इलेक्ट्रॉन्स विल फ्लो फ्रॉम नेगेटिव टू पॉजिटिव, वाइल इलेक्ट्रिक करंट जो हमारी कन्वेंशनल करंट होती है दैट विल फ्लो फ्रॉम पॉजिटिव टर्मिनल टू नेगेटिव टर्मिनल, राइट? Second one, electric current in the conductor. While we are talking about conductor, so we can classify materials in three categories. First one conductor, second one insulator, and third one semiconductor, right? Electric charges in motion due to the force experienced by the applied electric field constitute electric current, जिसकी वजह से क्या होता है, कंडक्टर में करंट फ्लो करता है. In solid conductor, the current is carried by the negative charge electrons. In electrolyte solution, the current is carried by the motion of positive and negative ions. When no electric field is applied, electrons are in random motion and the average velocity of the charges is zero. Therefore, there will be no net current. नेक्स्ट टॉपिक वेरी वेरी इंपॉर्टेंट, दैट इज ओम्स लॉ. बच्चों हमें पता है कि जॉर्ज सिमोन ओम हैव डिस्कवर्ड द रिलेशन बिटवीन पोटेंशियल एंड इलेक्ट्रिक करंट. सो इलेक्ट्रिक करंट can be derived with the help of potential, with the help of resistance. As we know that Ohm's law stated that the flow of current in any circuit will be directly proportional to applied voltage, right? I proportional to V, or we can say V equal to IR, where R is the resistance which is constant, which is depend upon the length of conductor, area of conductor, right? And the SI unit of resistance is in ohm. We can measure the resistance in ohm. Resistance is the property of conductor to oppose the flow of current, right? Come to next one, bacho, with the help of graph we can explain that Ohm's law. While we are plotting on x-axis current and on y-axis voltage, so we can get a straight line. So we can derive R equal to delta V upon delta I. Next one, 1 ohm is the resistance of the conductor which develop potential difference of 1 volt when a current of 1 ampere is passing through it. Basically बच्चों with the help of V equal to IR we can define 1 ohm resistance, right? Another important phenomena, the resistance of the conductor is depend upon the length of conductor, cross-sectional area, as well as resistivity, that is rho. So another mathematical formula, R equal to rho L upon A. This is very important, where rho is the resistivity and which can measure in terms of ohm meter. Next one, resistance and resistivity. Basically while we are classifying, why we are distinguished between resistance and resistivity, so these are the basic terms. Resistance is the property of substance by virtue of which it opposes the flow of current or charge. Resistivity is the specific resistance the property of the material of the conducting substance, and it is defined as the resistance of the conductor of unit length, unit area of cross section. And the unit of resistance is ohm, and the unit of resistivity is ohm meter. And the third point is a factor affecting resistance are length of conductor, area of cross section of the conductor, temperature of the conductor, and the nature of material of the conductor, that rho. And while we're talking about resistivity, factor affecting the resistivity are the temperature, number of density of the free electrons, type of conductor, and relaxation time. Come to next one, current density. Current density is defined as the current per unit area taken normal to the current is called the current density. It is denoted by J. Its SI unit is ampere per meter square, right? As with the help of Ohm's law, V equal to IR, we can derive V equal to J rho L, right? Basically current density is a vector quantity that will be equal to sigma into E, where E is electric field. Next one, bacho, drift of electrons and resistivity. Drift velocity. While we are talking about drift velocity is defined as the velocity of with which the free electrons are moving or drifting towards the positive terminal under the effect of an applied external electric field. Consider a conductor of length L, area of cross section A, and which an electric field E is present due to the potential V being applied. As an acceleration can be calculated by A equal to minus E upon m, where E charge and E electric field and m is mass of the electron. The electrons undergo collision. The average velocity of the electrons in the presence of an electric field is called the drift velocity, that is denoted by Vd. So Vd can be calculated as A into tau. A means acceleration of the electron and tau relaxation time. That can be derived as E upon m into tau. If n is the number of density of free electrons and n AVDT is the number of electrons crossing area A in time delta t, then current flowing I equal to delta Q upon delta T. By this formula we can also derive the relation as Ohm's law, and we can derive the rho equal to m upon n e square tau. So with the help of current and with the help of drift velocity, we can also derive the relation between V equal to IR as Ohm's law stated. Right. Next one, mobility, mu. Conductivity due to mobile charge carriers. Mobility mu is defined as the magnitude of drift velocity per unit electric field. Mu equal to Vd upon E, that will be E upon m into tau. The SI unit of mobility is meter square volt second, where V is the volt and S is in second. Limitation of Ohm's law. This is very important for board point of view. As we all know that in all conditions we can't apply the Ohm's law. So basically these three limitations of Ohm's law, V cases to be proportional to I. If V is proportional to I, then and then only Ohm's law can be applied, without or we can't apply where V does not proportional to the I. Second, the relation between voltage and current depends upon the sign of V. Basically the between current and voltage we have to consider sign, that is in diode we can't apply, in the semiconductors we can't apply Ohm's law because it can't follow the Ohm's law, and these are known as non-linear elements. Third one, the relation between V and I is not unique. If V and I is not unique, if we are changing the value of V, then I will be constant, then we can't apply the Ohm's law. Next one, bacho, as we all know that commercial resistors, there are various resistors which is used as a commercially in large scale. Commercial resistors are of two major types. Wire bound resistors, in that they are made by the winding the wire of an alloy, that is manganese, nichrome, and contestant. The resistance are in the range of the fraction of the ohm in the few hundred ohms. Second one, carbon resistors. They are made from carbon. They are compact, inexpensive and small in size, and their values are given using by the color code. We can find the value of resistor with the help of this color code. Basically color coding, we have a resistance having various type of colors, and that colors can with the help of that color we can find the value of total resistance of that given resistor, like black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver, right? So number we can use 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and the multiplier we are using like 1, 10 to the power 1, 10 to the power 2, 3, 4, 5, 6, 7. Tolerance we are using like 5, 10 and 20. For example, the resistor have a set of coaxial colored rings. The first two bands indicate the first two significant figures of the resistance in ohms. The third band indicates the decimal multipliers. The last band indicates the tolerance. For example, 27 into 10 power 1 plus minus 5%. Suppose the first color is red and second color is violet, so the number will be 27, and the third one is brown, so 2 7 into 10 power 1 plus minus tolerance, next color will be gold, so we can find the value of resistor as 27 into 10 power 1 plus minus 5%. Next one, electrical resistivity and its temperature dependence. As we all know, resistivity is depend upon the temperature, and rho T equal to rho naught 1 plus alpha T minus T naught. So this is the formula, mathematical formula for dependence of resistivity with resistance with temperature, right? As we have stated that conductor, semiconductor and insulator, in case of conductor the resistivity in the range of 10 power minus 8 ohm meter to 10 power minus 6 ohm meter, and in case of semiconductor resistivity is between conductor and insulator. Resistivity decreases with increase in the temperature. That's why in semiconductor the temperature coefficient will be negative. In case of conductor the temperature coefficient will be positive. In case of insulator the resistivity is 10 to the power 18 times of the metals, so it shows a very large amount of resistivity, so in that case current can't flow. And next topic is electrical energy and power. As we all know that electrical energy is the rate at which electric energy is converted into heat energy. P equal to VI, P equal to I square R or V square upon R. Electrical power is transmitted from the power stations via transmission cables. The energy loss through the transmission is called the transmission losses. It can be minimized by the transmitting electrical power at a low current and high voltage through the transmission lines. Power dissipated we can find the value by I square R, where P is the power of the device. Next one, combination of resistance. As we all know that in some cases we have to increase the value of resistance, and in some cases we have to decrease the value of resistances. So we have two options. While we want to increase the value of resistance, then we have to connect in series. So first one, series combination of resistance. If three resistance R1, R2 and R3 are connected in series, so the effective resistance will be R equal to R1 plus R2 plus R3. In that case the voltage will be divided as V equal to V1 plus V2 and V3. In series connection the current will be same throughout the circuit. Second one, in parallel combination, as we all know, if three resistance R1, R2 and R3 are connected in parallel, so the voltage will be same throughout the circuit and current will be divided. So the effective resistance will be 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. In parallel connection, dear students, as we all know that current will be divided, so I equal to I1 plus I2 plus I3. So this is the short descriptions of the chapter number 3, that is current electricity. I hope you will like this video, and please share and subscribe my channel so that you can get more videos related to your topic. Thank you. Have a nice day.